I think we're ready to get started for our next session. We have three fantastic speakers coming up. We have Paul Parkinson. He's a consulting member of our technical staff, and he's been working on transactions in the mid-tier and the database at Oracle for the past 19 years. Thank you, Paul. Welcome for joining us. Quasi Mensah is a director of product management, the database team focused on Java connectivity. I've known Quasi for several years. Quasi, thank you so much for joining us. It's always a pleasure. And finally, Martin Schmitter. He's an Oracle ace, and he works at RWE in Germany, and he leads the German Oracle users group. And we are so lucky to have Martin with us today. So everybody, you guys, thank you so much and welcome. So I'll turn it over to you guys to get us started to talk about microservices.
Thank you, Tammy. Okay, good morning, good evening, everybody, wherever you are. So as Tammy said, this is me, and with me, Martin and Paul Parkinson. And who we are, she already discussed what we do, so you already know. This is the session agenda. I'll give you a general overview of data-driven microservices architecture. Then Martin will talk to you about real-life challenges beyond technology. And then Paul will walk you through the application, the demo, and the labs. Okay, so overview of data-centric microservices. This is what you need to know. You need to have a cloud infra, you need to have containers, Docker or CRY-O, you need to have an orchestrator, Kubernetes is the leading one, you need to have a microservice framework, in our case, Helidon. You need to decide how your microservices will communicate. We need a service broker, we need a service mesh, we need observability. We need to define our services. How do we do that? And of course, we need to address polyglot persistence. This is data-driven microservice architecture. And of course, we're gonna look at convergence database. And finally, distributed transaction, the Saga pattern. So is this gonna be a fast pace? So bear with me. An overview of microservice platform with the Oracle Cloud Infrastructure. We have the OCI API gateway, which is sort of a mechanism to let you call into legacy traditional applications, as well as Java microservices and Polyglot microservices, which are microservices written in Node.js or Python, etc. So in the cloud native environment, you have your Kubernetes cluster with your Docker containers. You also have what is known as service mesh. I'll talk about this in a moment. And then on the other side, you have cloud services such as the Oracle databases, the ATP, the ADW. So those are other cloud services not part of the Kubernetes cluster. So we need a service broker, which is a mechanism to let microservices running in the Kubernetes cluster to connect to services, other cloud services outside the Kubernetes cluster. We talk about that. On the side, we have mechanism for observability and tracing, as well as monitoring, right? And all those can be deployed either in the public cloud or a private cloud. You need to decide how your microservices will communicate.
And basically, you can have both synchronous and asynchronous. So asynchronous has a number of advantages to synchronous in its loose coupling, the ability to send events to resource microservices that may be down. You kind of need to code to this fault tolerance kind of state of mind as far as microservices and networking and things like that. And then there's also a pattern called event sourcing in microservices where every time you manipulate data, you're sending a message describing the data that you've changed. And so interested microservices or whatever they may be can listen to this. And so that's the pattern that's generally used in microservice communication.
Hey, Paul, can you maximize the slides by any chance? Go into slideshow, that would be great. Yeah, that's perfect, thank you.
Okay, cool, yeah. And so event sourcing, I'll kind of double time it here since we're a little behind. But event sourcing is basically what I just mentioned as far as you're manipulating data and sending an event. And so one of the advantages, this is a very noticeable advantage with AQ, and it's very unique to AQ, is the fact that you can do work in the database and send a message within the same transaction. So your microservices don't have to be coded to be idempotent. And that's a major advantage, because usually that's something, you know, that's just put on the microservice developer, is that they need to code their service to be idempotent. And so when you're using the Oracle database, as I say, this is a completely unique feature. You have this atomic transactional event sourcing. Very quickly, service mesh is something that's become popular in microservices in Kubernetes. And more or less what this is an overlay on top of your container. So they're basically interceptors that sit in front of your microservices and allow you to abstract these kind of common concerns, such as security, blue-green deployments, tracing, and things like that. And so they've become very popular because it moves all of those common concerns out of the responsibility of the developer. I show this a little bit in the demo as well, an example. And then it becomes increasingly necessary and critical in microservices, since you have these services spread across the network, to have good observability and tracing tools. And so again, in the lab, I'll go into this a bit. These are some of the standards and the tools as far as open tracing and Jaeger and things like that for both metrics and tracing. Very quickly, there are actually a few approaches coming out now, but the standard CNCF, that's the Cloud Native Computing Foundation, standard for connecting Kubernetes to cloud services, in our case ATP, is this service broker architecture, and Oracle has an open service broker. And again, I'll show that in more detail later.
Data management in microservices. So those are the considerations: polyglot persistence, bounded context, whether you want to use a full-fledged database per service, either a PDB, a shard, or PDB sharded, or you want to share at the database level, like tables, schema, etc. Database connectivity could be synchronous or could be asynchronous using standards such as R2DBC for Java and some other mechanism. There are the notion of the API composition, but we don't have time to go over this. Paul will discuss a little bit CQRS. So you have heard about the polyglot persistence. You have heard about the Oracle Converged database and how it simplifies microservices development. The only thing I can add here is that per microservices perspective, we support, with the Converged database, you support the multimodal approach with one single engine, which means I can specialize PDBs for JSON data, for relational data, for graph data, etc. And other than that, moreover, I can have multiple models in the same PDB or same database. And why is that? When you want to build a rich catalog, for example, where you have images, text, etc., you cannot deal with that with one single model. So supporting multi-model either per PDB or within the same PDB is very important. And overall, you also can have a cross-model view of what's going on in your database or across your databases. Okay, so how do you design your microservices, data-driven microservices? First, you have to identify your what is called business context, such as sales, marketing, support, etc. And then you need to carve microservices within the bounded context, right? So you don't want services to straddle multiple business contexts. So that's the bottom line here. Then you need to design the microservices which is within those contexts. And by doing that, you ensure that most of the microservices will have local transaction. I mean, each microservice should only have a local transaction. So should not be dealing with distributed transaction. And if you were to split your monolithic application, you want to map modules within the context as a service. And if you also want to split your monolithic database, you want to split along the lines of bounded context. So you really don't want to cross those contexts. That's the bottom line. So, okay. And taking all this into consideration, we give you GrubDash, as Paul would like to call it, or GrubDash, as Sanjay likes to call it. So this is the microservice application that Paul will walk you through, and it embodies all the concepts that we have been discussing so far. I'm not gonna discuss it. Okay, to finish up, I'd like to touch on distributed transaction. So for example, if you order food with the GrubDash or GrubDash, and you're going through multiple services, ordering is one Saga because you have multiple transactions within that business transaction. If you're booking a trip, for example, it's a business transaction, and within that, you have to book airline, et cetera, et cetera. So each transaction is local. However, the entire business transaction can be committed or uncommitted. So what happens if I cannot book my airline ticket and I want to cancel the whole trip? Then somebody has to compensate, to undo what has been done by the other local transaction. Okay, so that's very important, and how you address that is very important. And now, final slide, how does the Oracle database addresses the Saga challenge? Well, we have multiple mechanisms you already heard or you already know about: the AQ, the transactional event queue, that's a message delivery. We ensure exactly once delivery. You can execute all the steps or remove any effect by compensating, and that will be supported by coming features such as database transaction support for Saga. Now, compensation takes a lot of development resources and time and testing and cost and complexity. So what if we could give you compensate-able, I make this word up, compensate-able data type? So this is coming in the future. And then if you have complex Saga, where human interaction is involved, where you have multi-party, then you probably need a mechanism such as the Oracle workflow. Well, you will hear about all those in future events. Okay, so now Martin will discuss real-life challenges, and in 10 minutes, Paul will walk you through the demo and lab.
Real-world challenges of microservices, and I added in DevOps environment. Sanjay asked me to talk a bit about the real world out there dealing with microservices and what will this mean to your organization and the challenges. If you can go to the next slide, please. Just a short introduction to myself. In a nutshell, information scientist. I work as IT professional since around 20 years, non-professional 30 years. I'm a ham radio amateur guy, if you know what that means. So I'm allowed to set up my own radio if I want to. Started already with version 7.3 in Oracle. That's quite a while. I worked as a network expert, as CCNA, and I did join the German Oracle user group in 2010, and I'm working actively since 2016 as regional lead and have been promoted to an Oracle Ace in the last year. I work with the RWE Supply and Trading GmbH. That's one of the biggest players in Europe supplying energy and gas. So if you need power, we can help you. But today I'm just Martin representing myself. If you could go to the next page and jump over it, as this is just a safe harbor. That's already in the middle of now. Talking about microservices, I think you can't mention microservices without naming DevOps as well, because modern teams used to make use of the idea of DevOps if they want to develop microservices as well. And since quite a while, more than 5 years, I discuss with our development teams what is really the benefit out of microservices and the DevOps idea and their self-conception. That's probably not what is written in the papers scientifically what it means, but that's what people think. They have the full freedom to choose the best tool for a given task. And that has an impact on your organization, a dramatic change, how we worked in the older days developing software, because the team will choose the technology and probably the product they want to use. And that was in the older days a different approach where we had a hierarchical situation where the IT department probably provides predefined and pre-configured tools that you have to use, and there was no choice. So that has a very serious impact how organizations have to move and change. And if you can go to the next page, please. Just some examples here that teams now need to consider if they start, or organizations, that is a dramatic change in the organization. Authentication, authorization, and monitoring. Some of these things have been already mentioned in the other presentation. So how can you deal with the complexity if you use multiple products and need to ensure that you can authenticate the user and give detailed privileges case by case or distributed transactions? So that is a new challenge. That is something where your organization needs to dramatically change and find new ways and processes how to deal with this stuff. Yeah, so that's a real world challenge, and that can push you back with your delivery. What is the intention of DevOps and microservices, having fast successes and being quick to market? So that contradicts this complexity. If you do not have a perfect process to implement security, that might push you back. How could you audit accesses? Yeah, that's once again, you probably use a document store engine, and it's probably not a similar product like your relational model or your graph database. And then you need to have a centralized monitoring system, and you need to collect log files. Probably you want to audit the access for whatever reasons, and that over multiple data services, that can be a challenge. Yeah, so you need to invent your organization in a new way that you provide these tools. Once again, that's big effort in the beginning, especially if you do not start from scratch and you have an old environment with old monolithic systems that you need to move into the new ideas. If you can go to the next slide, please. Data privacy and protection, the well-known famous European data protection law is probably well known. That has another challenge, yeah, as you probably had make use in the older days of just one data engine, probably a relational database. That was most of the time the situation. Then it was probably very easy to get out all the information you need related to a certain user. For example, you want to get all the data of a certain individual. Based on the data protection law, there is the right of access to inform, so everyone can ask you, what data do you store about him? If you want to answer the question, and it was probably very easy with a SQL statement to get all the data of the individual. If you have multiple data sets, you need a new idea how to access the data and provide them. So probably you are not aware about what data has been stored. Us teams have now the full freedom to choose their own technology and how they implement this. There's another way. They have their own guidance, and you need to make sure that they have the right boundaries, that they just store the data they are allowed to store. That's not a decision of the hierarchical organization anymore, or of the DBA. The team can decide on their own, and if we have schema on read situations with document stores, they might store any data they want, and then you will have the ugly situation at the end, probably, that's no one knows what data is really stored in the database or in the data set, and that will, based on the data protection law, quite a pity. Yeah? So you will be in trouble then. The other thing is, if you deal with financial data in Germany, for example, there is a tax law that will ask you to provide all tax relevant data in a certain format to the tax office. How can you do this with certain data engines. So you need another way, once again, to provide this, probably your own API to get all the data and the structure. But if you do lose control about all the services that have been attached to your data, you're probably, once again, not aware about all the data you need to deliver. So the big question is, can you make sure to be aware of which data you are using, or at least you need to invent a new data governance framework. Yeah, that's quite a challenge for a big organization as well. Next slide, please. And there's another thing that is quite interesting as well. So in the idea of cloud and cloud services, but not just cloud, that's not limited to cloud services at all. That's just in the idea of microservices and automatization. If you have the freedom to choose any product and tool you want, then you will face the situation that the amount of tools you will have find in your organization will grow, definitely. On the other hand, you will have a security department and other departments in an organization that want to know which tool you use and want to approve these tools with, and do certain assessments. For example, the use of private data or people relevant data, security hardening and all these things. So you will probably end up in a situation where you say, I want to use a Docker image, and your security department says, oh, we need to assess the image. Is it compliant? Is it secure? Is everything fine with it? Or probably they will say, you are not allowed to use any Docker engine image what you do not have provided on your own. That is, once again, a new way where you need to find boundaries to deal and satisfy all the processes in your organization. So that's really not that easy, and it's a lot of work to onboard or allow list new services in a big organization with all parties involved. So the initial step to make use of certain products is quite a lot of effort and time consuming at the end. And that might become to a quite interesting situation, as we said, we want to have the freedom to choose our own tools and want to use the tools we want to. That will lead us back into a situation that we'll probably discuss. Let us consolidate all the tools we use and find certain specific tools and consolidate our skill set on these selected tools and make sure that we do not have too much tools in our organization. Yeah, so that is contradicting the idea, at least of the self-conception of the DevOps teams, to have the freedom to use what they want. So you will have a lot of noise in your organization until you find the best way how to deliver all these ideas. Next page, please. And I hope I made it on time then, it's exactly 10 minutes. Leading to the question to the audience, what is your best practice to deal with all these challenges? We already see some ideas how we can deal with this from Oracle, and I'm pretty confident that Paul has some good ideas in the follow-up now.
This is the lab I'll be going through. And we'll have this link, and also I'll be monitoring Slack all the time. So if you have any questions, please forgive the fast pace, and I'll be able to definitely address them afterwards if you have anything you want to know more about. So as I say, this is the lab. We have that on Oracle Learning. And this is the architecture that Sanjay showed and explained. And then we have the different breakdowns of the labs. So the first lab here is setting up basically your infrastructure as far as services on the cloud. So by the time you're done, this first lab takes like less than an hour. You'll have all your repository for your images, your object storage, your databases, your PDBs, and all of that set up. And then in the second lab, you go ahead and start getting into the dev process. You grab the code down and deploy your first microservice. And that's just the static front end for the app here. You then go ahead and connect a microservice from the Kubernetes cluster here, from the OKE cluster, to the ATP PDBs you've created. So that's kind of your first step, this connectivity. And so the way you create that initial connectivity is by using a service broker. And what that service broker will do will create what's called a secret in Kubernetes. And so during this presentation, I'm going to go back and forth between the lab and the app, which is the screen here, and the underlying source code and Kubernetes YAML resource descriptors, which is what we see here. So you've created your database, your OKE cluster, and you have a basic microservice in the OKE cluster. You've then gone and used the service broker to create a Kubernetes secret. Your next step is to refer to that secret in your deployment YAML. This is like in whatever world you come from, your deployment descriptor for your service. So in this case, we have the order service here, that's your image. And here we've mounted that secret, which has all the credentials and connection information for your ATP data PDB. Now that that's mounted, you can refer to that. For example, you can refer to it as your TNS admin when you're setting up your URLs and your environment for your microservice. So we have user, password, URL here. Now, all of the microservices in this demo, in the initial demo here, are Helidon microservices. So just very quickly, Helidon is a platform. If you're familiar with, I think maybe the easiest way to describe it in a sentence is if you're familiar with an application server, Helidon is sort of an application server geared specifically for microservices. And so with Helidon, we decided to have two versions, one called SE, which is very functional in style, very reactive. And they actually, we released version 2.0 of both of these, and there's extended support for the Graal VM in both. And then the Helidon MP, which is what we'll be looking at here, which is really tailored towards people coming off of the monolith world, off the Java EE world. Developers can very easily port over using this microprofile standard, which maps nicely with the Java EE world. So it makes the migration very easy. And so one of the things we have in this microprofile standard is these microprofile properties. And so this is in your microservice, and you can see these properties here are the same ones that you brought into your environment in your Kubernetes YAML. And so your application then has access to these, and using Helidon MP, that resource is then can be automatically injected into your microservice. And so this is all you had to have in your microservice code to have connectivity from your Kubernetes microservice into your ATP database. And so you have all of that going within 2 hours of this lab. So it's nice, very easy. You don't have to code any connection materials or anything like that. So that's our first step, connectivity. So this is the app that is in the workshop, and it started out as Veggie Dash, but the same way we've been evolving this app to include what you'll see in the following sessions as far as text search for recommendations, the spatial, the nicer front end. It's an improvement upon this for sure. We've evolved it to GrubDash. So it's not just vegetables anymore either. So, but this is the same application we'll see built throughout this seminar. And one of the main tasks, these are setup tasks here, that I'll be talking about as far as the concepts that Kwasi brought up with data-driven apps is this task 9, which exemplifies a saga that Kwasi was talking about. In this case, it's a choreography saga, which just means that it's a saga that is controlled between two microservices. You don't have an arbiter of an orchestrator. So in our case, we have an order inventory scenario. We have the customer placing an order. If the inventory exists, their order is successful. If it does not exist, then it is unsuccessful, and you need to compensate the transaction, roll it back, in older terms. You need to compensate it. So in this case, just going through the example real quick, if we get the inventory for cucumbers, it's currently 0. So if we go ahead and place an order for them, it's going to fail. So we see the order is pending, and then when we go to show the order, we get the expected fail due to the fact that there's no inventory. And then if we go ahead, let's just clear the order so I can use order 66 again, and add inventory, we now have enough inventory for the order. And so when we place it and show the order, we see that it's successful. So in the failure case, our compensation action was to set the order status to failed. But since we have inventory in this, we can complete the Saga and show inventory exists. The other thing to note here is aspects of the inventory location and the suggestive sales. So what we see here, and I'll show you the architecture a little closer in this trace in just a second, but what we see here is an example of what's called CQRS, and that stands for Command Query Responsibility Segregation. So in older technologies, generally you use the same approach for your commands and your queries. You would use JDBC or SQL or whatever to do your inserts and your selects. Well, because we're moving to more of an event-based system and to provide decoupling so that you can scale optimally, the microservice world is adopting this CQRS pattern. And a lot of these patterns are actually older, but they're finding the fit in microservices world. In CQRS, and in this example in particular, we're using the command to insert the order, and we're inserting that in JSON format. And then for the query, we're actually querying based on events. When Kwasi and I were talking earlier about event sourcing, I was saying how microservices listen for events they're interested in. So this order service has been listening for events related to this order 66. And so it's been listening for events from the inventory service, suggestive sales, and things like that. And that's how it built up internally the query of the order status overall. It did not do a SQL, select, even, there are acceptable patterns, materialized views and things like that. But in this case, we're building it up on events. It did not need to do a select across microservices or anything like that. It was nice and isolated, and we had our bounded context and all of that. So let me just show you, now that I've just shown the run through of the app, the actual kind of flow and architecture underneath. So this is a tool called Kiali, and it provides tracing by drawing the Istio service mesh we touched on a little bit earlier. And so these type of tools are very necessary really in a microservice environment, because you need to be able to trace across all these various different processes. And so here we see our front end being contacted by the internet here, and that front end contacting the supplier to add and remove inventory, and the order to place an order. So what's happening here is we have the AQ event sourcing. So we have an atomic insert of the JSON order. And for supplier, we are using relational, by the way. We're using all these different converged database data types. We inserted the order in JSON format, and in the same atomic transaction, we sent a message of order placed. And the inventory service was interested in that, picked it up, checked the inventory, and put its own message indicating if the inventory exists for that order. Again, all in the same transaction. Then, rolling it back, the order service picks that up, sees if its order is successful or not, issues the compensation if necessary, and returns that to the front end. So the key part here is that there's no line between the order service and the inventory service, nor the front end and the inventory service. It's all event-based. So that kind of covers that concept of the data aspect. Now I'm going to go into some other areas related to microservices, and certainly related to assisting in data-driven apps. So one aspect is just collecting various metrics. So here we can see metrics in Prometheus format, which can be viewed in tools like Grafana. And so this was very easy with Helidon. If we go back to our app, and this is our place order method, we just place this annotation for timed here. And that gave us automatically collected metrics and advertised those for the time spent in that place order app. So very handy. Another handy feature of Kubernetes and OKE in general, but is made very simple with Helidon, is this use of health probes. So here you can see we can check whether our microservice, again, this is the order service, is live, and not just live if it's ready to take requests. Okay, and so if we go back to our source here, oops, if we go back to the source, this was very easy to do. And in our deployment descriptor, we just put this liveness and readiness probe definition here. And what this says is for Kubernetes, for OKE, to come around and probe the liveness of this container, of this microservice, and every so many seconds or whatever, and you can check a URL, whatever, a file, things like that. And if it's been down for a certain amount of times, then go ahead and restart that container. So you can see it's a very robust, reliable feature to have these readiness probes. And in our Helidon app, all we had to do was implement this health check and return, the information on the health of that. So it's great for giving feedback. And again, it's very easy to add it. The next thing I'll talk about is tracing. So this, again, tracing is critical to microservices. And so the standard for collecting tracing in the microservices world is open tracing. And so that's widely adopted. That may be the most, if not, or one of, if not the most adopted standard is open tracing. So all of the products use this. And so going back to our microservice again, I simply added this tracing annotation, and we're able to trace that advertises open tracing information that can be then consumed, things like that. And so what we see here is a trace coming all the way from WebLogic into Helidon into the backend database. And so we can do this tracing all the way down. And if you drill into it, you can attach all of this information, such as our order ID, our Saga ID, and things like that. So very valuable. And then we have, I won't go into this because this demo takes a number of minutes, but we have the OKE horizontal auto scaling. And so what you can do here is define a scaling rule. And if that rule, for example, in this, we use CPU stress. You can say if the CPU stress on this microservice exceeds a certain amount, or if your connection speed to the database, whatever it may be, exceeds a certain amount as defined by this rule.
Same again.
So it's this nice automatic auto scaling. So that's what's great about the microservices too, is all this decoupling, the ability to independently scale, and the fact that you can bring out all these common concerns so that you can, design a robust service, using, like in Helidon, using just some basic annotations and things like that. And then lastly, I just wanted to tie in, we don't have time to go into security aspects, but Martin brought up, considerable real world security aspects. So I just figured I would mention also the security annotations in Helidon and the overall dock location up there. And I think I talked pretty fast, but I got it in there. So with that, I think I'll hand it back.